Welcome into integrating vector valued functions. Right, so essentially, right, let's say if I want to take the integral of r of t dt, right, if I know how to take the integral in 2 dimensions, which was calculus 2, right, we had some integration techniques including reverse power rule, right, integration by parts, trigonometric substitution, U substitution, all of those can come back into play now, but if I'm integrating, all I'm going to do is I'm going to integrate each individual component function with respect to t. Right? It should come as no surprise since this is the same way we dealt with derivatives, right? So the integral of g of t dt and the integral of h of t dt. Right? So essentially, again, we just have 3 times as much work as we did in Calc 2. But let's go ahead, we'll do an example problem here. Right, and I'm going to throw in a couple of curveballs just to get us used to our integration techniques we should know. Right, so let's say if I have the integral of r of t is equal to, and I'm just going to go ahead and write in all the integral signs. Let's say we do the integral of t over t squared plus 1. As we write these, we kind of want to identify what type of integration technique we're going to use. Right, so that's one of them. Let's do the integral of 1 over t dt. And we'll do our last one as, let's do the integral of secant squared t dt. And we will close out the vector. Right, so 3 different integrals. We can see them here. Right, we want to do each one by one. Now the very first one is kind of the trickiest one here, right? So maybe we might want to stare at it for a second. The integration technique that we're going to need to use here is U sub. Right, we need to do a U sub problem. And again, the more integrals we do, the easier it is to identify what type of method we should use. Right, so in this case, I'm going to do a U sub. So I'll say U is equal to, we're going to do t squared plus 1, which means that du is equal to 2t dt. Now let's pause for a second and look at what we have. Right, so I'm going to sub out the t squared plus 1 with the u. We still have a t dt left. Over here I have 2 of them, so I want to solve for this thing by itself. So let's move the 2 to the other side, and now I have a 1/2 du t dt. Okay, so we're making progress. Let's go ahead and move from t land over to u land now and make this substitution. So we have the integral, I'm going to put the 1/2 on the side of 1 over u du. Right, so again, I subbed out the t squared plus 1 for the u, and this t dt here, right, t dt is equal to 1/2 du. Right, so I just made the substitution, and now this is a fairly straightforward integral, which will also help us here. This gives us 1/2, right, natural log of u, and absolute value signs are fine right now. We'll assume the domain's okay, plus c. Right, and again, we're going to put plus c's for all of these, but I'll just put plus c1. Okay, and we don't want to get stuck in u land. We were in t land, we went to u, now we want to go back to t. Right, so we have, this is, we'll say equal, we have 1/2 natural log of, well, what did u equal here in our case? T squared plus 1 plus c. So that is our first one. Right, so again, if we're not familiar with USub, I am making a side quest video. So there is that. Feel free to go check out that video. Get used to USub because we are going to see it much more in this class as we move forward. And if you are planning on taking differential equations, again, as I mentioned, the whole class is using integration techniques. So please go review. There should be a link to the video somewhere on the screen. Okay, so now the next one, which should be fairly easy because we just did 1 over u. Now we have 1 over t, right? So this one's more straightforward. we have natural log of t, and we'll just say plus c2. And our final one, right, we might have to think for a second, what function, when I take its derivative, I get secant squared of t? Right, so what function, when I take its derivative, I get secant squared? Well, in this case, right, it's going to be equal to, this is going to be tangent of t plus, and we'll just say c3. So our final answer, let's carve out a box for it here. Right, our final answer of the integral is going to be equal to, we have the 1/2 natural log of t squared plus 1. We have the natural log of t, and we also have tangent of t. We'll close that out, plus c vector, right? Okay, so that is our final answer here. Right, again, all we need to know are our integration techniques from Calculus 2, right? So if we're good with those, again, we should have a link somewhere for USub. And the next part of this video, we're gonna go through another problem. We'll see integration by parts. I'll put another side video, so look out for that. And we will go from there. So I will see you in the next part of the video. Welcome in. We're going to do one more, right, integration problem, except now we're going to do integrating by parts. Okay, so let's go ahead. I'll give us an example of what we're going to solve. Let's go ahead and do the integral, and we'll do, let's see, how do we want to format this? We'll do cosine of 2t I, so we'll write it out in physics form, plus t e to the t j, and lastly we'll do a nice easy one, plus the square root of k, square root of t, I'm sorry, k. There we go. dt. Mistakes happen. Okay, right, so 3 different parts, 3 different, right, integrals to solve for. We're going to break it up one by one as we normally do. Right, as we go through these, we need to know what type of integration technique to use. So let's write out this first one. Let's say the integral of cosine of 2t dt, right? This is the first one. And let's just deal with this for right now. This is a mini U substitution problem. Now I'm going to go through this one fairly fast. Again, I did add another video if you want to go watch a U substitution video on its own from Calc 2. That should be added. In this case, right, think of like a backwards type of chain rule, right? So if we're doing derivatives, we'd be multiplying by 2 when we do the chain rule, but now when we're going backwards, we're going to divide by 2, right? So when we solve this integral here, the backward step from a positive cosine is going to be a positive sine. And instead of multiplying by 2, right, we're just going to divide by 2. And I'm going to put a plus, we'll put a plus C1 here. All right, so this is our first one. All right, so kind of like a mini U sub if you want to do U sub, or if you've done them enough, right, we can see the pattern that goes with this. Now our next one, t times e to the t. What do we do with this? Well, this introduces the concept of, well, it doesn't introduce, we're bringing back the concept of integration by parts. Right, so let's write this down. We have the integral of t e to the t dt. Okay, now I'm going to write down, or we should see what integration by parts is. I'll just have the formula show up, right? So integration by parts, we need to pick one of these to be u and the other one to be dv. Right, so in this case, I'm going to set my u to be whichever one is going to help when I take the derivative. So which one is going to be nicer when I take the derivative? In this case, u is going to be equal to 1, or I mean t, sorry, getting ahead of myself. And du, the derivative of t, is going to be 1 dt. So if this t is u, that must imply dv here must be equal to e to the t dt. And if we're taking the integral of e to the t, which is v, it's just going to be e to the t. Okay, so again, now this is coming straight from our formula integration by parts. Putting this all together, we have this is going to be equal to uv, so t e to the t, that's uv minus the integral of v du, which is 1 dt. And the reason why, so this is, again, let's pause for a second. The reason why we chose u to be t is that when I took its derivative, it gave me something nicer over here to deal with my integral, right? This 1 dt is very nice to deal with. So finally, right, our answer is, we have t e to the t minus, well, the derivative, or the integral of e to the t, we already know what that is. It's e to the t plus some constant, we'll call it c2. Awesome. Okay, which leads us to our final integral. We saved the easiest one. This is, I know it's confusing whether it's a k or a t. It is a t. That is our independent variable here. So the integral of the square root of t dt, and again, these square root signs, once we get to calculus, are a little bit unhelpful. So let's write it in a form that's a little bit easier for us to deal with. Okay, and now we just have a reverse power rule, right, where we're going to add 1 to our exponent. So now we have t 3 over 2, right, by adding 1. And instead of dividing by 3 over 2, right, that's an ugly way of doing it, we can multiply by the reciprocal, right, which is 2 over 3. And again, plus c3. Okay, so now we've gone through each part, right? We had this mini u substitution. Again, watch the video if you need to. Integration by parts, we have our rule for integration by parts over here. I will have another side quest video if you want to go through integration by parts by itself. That will be available to you. And then we have a reverse power rule. Now all we need to do is stick everything together and let's see what we have. Right, so the integral is going to be equal to, we have sine of 2t over 2 plus, or not plus, sorry, comma, almost, t e to the t minus e to the t, comma, 2/3 t to the 3 over 2. We'll end this, and then we'll put some plus some c, which is a vector, right? Awesome. Okay, so go through each one of these individually. Again, if you need to see integration by parts, please review it now before we get further down the road, or you're in differential equations and now you're trying to reteach integration by parts and all your other integration techniques as well as diffie-qs at the same time. So now is the time to review. I will see you. We have one more example to do. All right, let's do this final application problem in which I'm going to give you the acceleration vector. So we'll say, let's try that again. A of t is going to be equal to, we'll do negative 3i minus 2tk. And I'm going to give you some initial conditions. We're going to need these down the line. Not quite yet, obviously, but in a second. So we'll say over here we have v0 is going to be equal to 3i minus 3j. And we also say r0, right, the position function at 0, is going to be equal to j minus k. So we'll save these for later. Right, so I want to work down from the acceleration vector, right, space curve, to the velocity vector. And so how do I do that? Well, by integrating both sides, right, if I take a of t here, dt, and I integrate both sides here, right? Well, what do I get? Well, that means that this side, right, this is going to simplify to be v of t. And let's think about what's happening here. If we take the antiderivative, or the integral of negative 3, we're going to end up with negative 3ti. And if we take the integral here of minus 2t, we're going to end up with minus t squared. And of course we have k plus a constant c1. We'll just put c. Right, since we're dealing with the entire vector. Okay, so what we need to pay attention to here, right, is maybe we write this in vector form too. Just, it might even be more obvious. We can leave it for right now, but what do we notice? If we plug in 0, so let's go ahead because we have this initial condition of 0. So let's plug in 0 and see what happens. V0, well, this is going to be equal to negative 3 times 0. Well, this is 0. Negative t squared, right? So 0 squared is 0. So we're just left with c. And we know that c is supposed to be equal to, right? V0 is supposed to be equal to 3i minus 3j, which means c must be equal to 3i minus 3j. Right, so what we're going to do now is we need to take what we found here for c and plug it back in, right, to our velocity vector. So we're going to combine what we found for c and plug it back in. So our actual velocity vector here is going to be, and I'm going to write this in vector format now. We have negative 3t, and we also have a 3 from here, right? So plus 3. So again, we have this negative 3t, we have this 3 here, since they're both i's, right? They're both the first component. Comma, let's figure out what our next piece is. Well, we just have negative 3j, so negative 3 is by itself. Negative 3. And our last piece is just the negative t squared by itself. Okay. All right, so now we have it in vector format. We're just getting used to both physics and vector format here. What's our next step? Well, we have our, right? We have our velocity. Now we want to go to position. So taking the integral of both sides here, right? And you can just, this might be improper notation, but we'll write it out. But I don't want to do extra steps, so let's go ahead. We have the integral of v of t is dt is going to be equal to, and we just have to do each one of these separately, right? So let's just go down the line here. This is now going to be negative 3t squared over 2, right? Backwards reverse power rule. Let's make this t look like a t. T squared plus 3t minus 3t, comma, minus t cubed over 3. Awesome. Okay, and of course we have to put plus, right, some other vector here. We'll call it d, right? I'm calling it something different than c in this case because they don't have to be the same, right? So in this case, plus d. And again, I have what r of 0 is. Well, I know that this, the integral of v of t, is r of 0, or r of t. So let's just go ahead and plug in, right? This is r. And let's plug in 0 here and see what we have. Well, if I plug in 0, I'm going to end up with 0 here, 0 here, and 0 here, plus d. Right, and what do I know? Well, I know that when I plugged in 0, I was supposed to have j minus k, right? Which means, right, what does that imply? This must be that j minus k, and I'll just write this out in vector form, right? This is 0, 1, negative 1, right? D must be 0, 1, negative 1. So again, same step we did here. We found out what this constant was and we plugged back in. And same thing, we found out what this constant vector was, D, so let's plug it back in. And so our final answer for R of t is going to be R of t is equal to, we have negative 3 over 2 t squared plus 3t. This is done, right? Comma. Next, we have negative 3t from here, and we have a positive 1 here, so negative 3t plus 1, comma. Next, we have a negative t cubed over 3, and we also have a minus 1. All right, so we have our final answer here, right? So in this case, we just had a bunch of reverse power rules going all the way down. We threw in some initial conditions, so we have to go find the constants as we go backwards, but straightforward enough. So again, I've included both the U-sub and the integration by parts videos. If you want to go watch those, they're going to help greatly, especially again once you get into diff-EQs. I know I keep bringing that up. But that is it for this video. I will see you in the next one next week. See you guys.